Imagine a place where time stops, where light is swallowed whole, a black hole. What if you were drifting, alone, toward that endless darkness? Science tells one story. Reality may whisper another. Stay with me, and you'll see exactly what happens when you disappear into a black hole. Black holes are not monsters of myth. They are real, measured, and terrifyingly powerful. They bend space. They bend time. They bend everything that comes close. In the next few minutes, we will follow a human body, step by step, from the horizon to the singularity. By the end, you'll know the exact sequence of events that would unfold inside the darkness. Let's begin the descent. The event horizon is the point of no return. It is the surface where the escape velocity equals the speed of light. Cross it, and you're trapped forever. Gravitational time dilation takes hold. 1 second for you becomes years for an outside observer. To the distant universe you freeze, a ghost on the edge of forever. Your ship's clock slow. The external cosmos races forward. Crossing the horizon is only the beginning. Now the tidal forces start to stretch you. Gravity pulls stronger on the side nearer the hole. Your head feels a stronger pull than your feet. The force grows as one over the cube of the distance. Near a stellar mass black hole, it becomes lethal within meters. Your body elongates, a thin strand of matter, a noodle of existence. While you are torn apart, the universe outside continues its dance. If the black hole spins, a second horizon appears, a hidden doorway. The inner, or Cauchy, horizon lies deeper. Past it, the laws of physics as we know them break down. Predictability vanishes. Your fate becomes unknowable, even to the equations that describe you as before. And finally, the inevitable, the singularity. All that you are is crushed into a point of nothing. Density and curvature become infinite. General relativity predicts a breakdown. Quantum gravity is needed to describe what follows. The universe ends for you in a single, timeless instant. What do you think? Let me know in the comments. But the story does not stop at the singularity. There is a deeper mystery that lingers in the dark. The universe whispers that information cannot simply vanish. This is the heart of the information paradox. Physicists have wrestled with it for decades. They ask, does the black hole erase what falls in, or does it hide it somewhere unseen? Stephen Hawking proposed a radical idea. He suggested that black holes are not completely black. They emit a faint glow, a quantum leakage that we call Hawking radiation. This radiation is born from particle pairs that flicker at the edge of the horizon. One particle falls in, the other escapes, stealing a tiny amount of the black hole's mass. Over unimaginable spans of time, the hole shrinks, releasing its stored energy back into the cosmos. If this process truly occurs, then the information about everything that fell in might be encoded in the radiation. It would be scrambled, like static on an old television, but not lost. The mathematics hints at a subtle imprint, a fingerprint on the escaping photons, yet we have no way to read that code. The theory remains incomplete, a tantalizing hint that quantum mechanics and gravity must eventually unite. Some researchers argue that the horizon itself is an illusion. They propose a firewall, a searing wall of energy that incinerates anything that approaches. In that picture, the smooth passage we described earlier never happens. The astronaut would be vaporized instantly, his atoms turned into high-energy particles. This radical view challenges the notion of a gentle stretch. It forces us to rethink the very fabric of space-time. Others suggest that the interior of a rotating black hole could be a bridge to another region of the universe. A wormhole, perhaps, connecting distant galaxies, or even another universe altogether. The mathematics permits such tunnels, but the reality is unstable. Any perturbation would collapse the passage instantly. Still, the possibility fuels the imagination of scientists and storytellers alike. Regardless of the exact details, one thing is clear. Black holes are laboratories for the extremes of physics. They push our equations to their limits. They reveal where our understanding cracks. By studying the way matter is torn, stretched and compressed, we learn about the nature of gravity itself. We learn how space and time respond when pushed to the brink. The journey we have traced, from the point of no return, through the tidal stretch, past the hidden inner horizon, to the final collapse, serves as a roadmap of those extremes. Each stage offers a glimpse into a regime we cannot recreate on Earth. It is a natural experiment written in the language of the cosmos. What does this mean for us? Watching from a safe distance, it reminds us of our place in the universe. We are fragile, bound by the same laws that govern the most massive objects. Yet we possess the curiosity to explore them, to model them, to imagine what lies beyond. If you found this descent into the unknown compelling, let me know in the comments. Share your thoughts on the paradox, on the possibility of a firewall, or on the dream of traversing a wormhole. Your insights add to the conversation, and together we push the frontier of understanding. And if you want more journeys into the deepest corners of physics, consider joining the channel. Your subscription fuels the research we bring to light, and it keeps the curiosity alive. Hit the like button if this video sparked a question in your mind. Every click helps us explore the mysteries that still hide in the shadows of space. In the end, the black hole remains a symbol of the ultimate unknown. It challenges us to look beyond the horizon of what we think we know. It asks us to confront the limits of our perception. As we continue to probe its secrets, we may uncover not only how the universe works, but also why we are compelled to seek answers at all. So keep looking up, keep questioning, and remember, the next great discovery may be waiting just beyond the edge of a star-filled night. The darkness you have imagined is not just a void. It is a laboratory where the rules we trust are tested to their breaking point. Every photon that disappears, every particle stretched beyond recognition, whispers a secret about the fabric of reality. If we could stand on the edge of that abyss, we would hear the echo of a universe that refuses to be simple. What would you feel if you could watch that final flash of light, the moment the stretched strand of matter collapses into pure curvature? You would feel awe. You would feel the humility of a mind that finally meets the limit of its own comprehension. That is the power of the black hole story. It forces us to admit that there are questions we cannot answer with the tools we have today. And yet, this is not a reason to surrender. It is a call to push deeper. Researchers are already building the next generation of telescopes, sharpening the equations that might one day unite the large and the tiny. They are hunting for the faint whispers of Hawking radiation, the faint glow that could prove that black holes are not eternal prisons, but objects that slowly evaporate. Each new observation tightens the knot of our understanding, and each failed experiment reminds us how much is still hidden. So here's where you come in. If the idea of a stretched noodle of flesh turning into a point of infinite density, sparked a question. Share it. Tell us what part of the descent terrified you the most. Did the notion of time freezing for an outside observer make you wonder about your own mortality? Did the hidden inner horizon of a spinning vortex ignite your imagination about wormholes and shortcuts through space? Your thoughts become the fuel for the next round of inquiry, and they help shape the dialogue that drives science forward. If this journey into the heart of darkness resonated, let a light ripple across the screen. It signals that the quest for knowledge matters, and it encourages the channel to keep digging into the most extreme corners of physics. And if you want to keep walking the line between wonder and rigor, consider subscribing. Each new subscriber adds a voice to the chorus of curious minds daring to ask the impossible. Remember, the universe is a tapestry of mysteries woven together by gravity, light, and time. Black holes are its darkest knots, but they also are the points where the pattern becomes visible. By staring into that darkness, we learn not only how the cosmos works, but why we, as conscious observers, feel compelled to seek meaning in the unknown. Stay vigilant, stay curious, and keep looking up, because the next revelation may be waiting just beyond that star-filled horizon.